So you have a rocket that has, I draw a really nice rocket. It's got a big M, right? It's got a lot of mass. And we want it to have a velocity up. So how do we get that momentum up? We have to have mass going down. It's a little mass, but it's got a big V, and it's down. Right? Because when the rocket was stationary on the ground, its momentum was 0. So the momentum afterwards, when the rocket's moving, the mass of the rocket times its velocity has to equal the mass of the gas times its velocity, but negative, because it's all got to equal 0. Momentum at the start equals momentum at the end. Make sense? Pulse is I, and it's measured as force through time. So a lot of force over a lot of time will give you a good high impulse, or small force over a really short period of time will give you a high impulse. Okay? The neat thing about impulse is, if you look at the units, it's Newton seconds, or kilograms meters per second squared times second. So that second cancels with that, and we're left with kg meters per second. Now, where have we seen that before? Momentum. So then impulse equals momentum. Or it can be written as force times change in time equals mass times change in time, or velocity. Fat math. So we know also that PF equals to something's going one way and something else going the other way. So what mass is going one way? The boat plus the child is going one way. So 80 kilogram boat plus 20 gram child. The child's staying on the boat. He's not going anywhere. We don't know their velocity. Plus, the only thing that's left is the 5 kilogram package, and it's going 10 meters per second. So 0 equals 100 V plus 50. V equals negative 50 divided by 100 equals negative 0.5 meters per second. It doesn't matter if this is negative as long as it's opposite sign to this one, because the boat's going one way and the package is going the other. Okay, so forgot to mention, if you haven't done it already, put a big square around that formula, because you'll need it for a test.
Yes?
You're going to need that formula for a test now.
I wrote that point down.
Okay. Make sure you have put a big star, hint, hint, wink, wink. Hint, hint, wink, wink. So force times time equals mass times velocity. So force is what we're looking for. Our time is 2 seconds. Mass is 2,000. And our velocity is 60,000 meters per second. Force equals 2,000 times 60,000 divided by 2. And force equals 60 million newtons, or 6 times 10 to the 7 newtons. Whole lot. Okay, so 150 kilogram astronaut acquires a speed of 2.5 meters per second by pushing off with his legs from a 2,200 kilogram space capsule. A, what is the change in speed of the space capsule? And B, what is the force exerted if the astronaut pushes for 2 seconds? So we can figure that one out. So
You always figure that out.
we always have to figure out our initial momentum. Yeah.
You just finish round right, like
Our initial momentum.
zero to zero.
Uh,
Yours to every single time.
okay, so momentum equals mass times velocity. Initial equals, like we said, mass. It doesn't matter which mass because our velocity is 0. So our initial momentum equals 0. No energy is added to the system. So PF equals PI equals 0. So our final momentum has to equal 0. Okay? So final momentum is equal to our mass 1 times our velocity 1 plus our mass 2 times velocity 2. And Mary asked, does it matter which mass is mass 1 and which mass is mass 2? No, it doesn't. As long as the mass goes with the right velocity. So 0 equals, I'll just say 2,200 times V1 plus 150 times 2.5, yeah. So 0 equals 2,200 VI, or V1 plus 375. And our velocity of our spaceship is then negative 0.17 meters per second. So part B, force times time equals mass times velocity. Doesn't matter which mass and which velocity you choose as long as it's the same ones. So we'll just use the astronaut with his velocity. .375 is force times where do I have that? 0.2. force equals 375 divided by 0.2 equals 1875 newtons. So we got to find our initial momentum. Stefan. Okay, our initial momentum is equal to our m1 v1 plus m2 v2. In this question, we don't have to change our velocities to or convert our units because it's all the same. So we have 1,000 kilograms times 80 kilometers an hour plus 1,500 kilograms times 40 kilometers an hour. So it's 80,000 plus 60,000, 140,000 dollars, kilograms, kilometers per hour. So then our final momentum equals our initial momentum. Final momentum equals the mass of the two cars combined plus 150 or 1,500. We're looking for our velocity, 140,000 equals 2,500 kilograms. Stefan. Our velocity equals 56 kilometers an hour. Backwards. So our final momentum 0 because our final velocity 0. So PF equals, doesn't matter what our mass is. Times V 0 equals 0. Okay.
Oh, so we stop. It doesn't matter.
Yeah. The mass is going to be the mass of the leprechaun plus the mass of all the bullets that are inside. So our initial momentum equals our final momentum equals 0. Our initial momentum equals the number of bullets times the mass of those bullets times their velocity. Well, because there's going to be more than one bullet going into him. We know that.
What's the N?
N is number. It could be N, X, whatever. Plus the mass of the leprechaun times his velocity. So 0 equals N times 0.06 times 900 meters per second plus 40 kilograms times 10 meters per second. So 0 equals N times here. 400? No, sorry. 54. N times 54 plus 400. Bring the 400 over. Oh, sorry. One of these is going to be positive, one is going to be negative, our velocities.
Yeah.
So that'll be a positive 400, sorry. So N times 54. Divide on both sides, and we get N equals 7.4. So
7 bullets.
So it'll take 8 bullets to stop him. And at 8 bullets, he'll actually be going backwards. So this is just a fat math one. Fat math.
We have T equals MD. So we force and time.
So force, time. Oh, sorry, and there's also an N in here because,
Number of bullets.
yeah.
How do you strike a wall at a rate of 10 seconds?
Oh, sorry, no, we won't have that N on there. We'll just have, sorry, we'll just have MV.
So
It's 10 per second.
Oh.
10 bullets per second. So our time is 0.01.
Okay, I got you. 0.0.
Yeah. Mass is 0.0.
Point zero or
Point 1.
Okay, so why is it?
Because it's 10 bullets per second, so one bullet would take 0.1 seconds.
four bullets?
And our velocity is 300,
600.
so our force equals 0.02 times 300 divided by 0.1 equals 60 newtons.
What? What is the? What's the force of the wall?
So that's the force on